So in this case, what this is saying is that there's a very strong effect. If you're adding a child to your family, there's a very, very good chance in this case that you probably will buy a new vehicle, but you are 7.5 times more likely to purchase a new vehicle if you added a child than if you didn't have a new child in your family. So in this case, this is a fairly strong effect. Any questions here? This is a little bit different too, because this is again a dummy variable. So dummy variable is always comparing the on state to the off state. Okay? Unlike income and oldest vehicle, where you can talk about for each additional $1,000, or you can talk about for each additional year, what we're going to be comparing is we're always comparing when that dummy variable equals 1 to when the dummy variable equals 0. So the coefficient, or the exponential of the coefficient, in this case is just talking about how many times more likely are the odds. So how many times more likely are the odds if you have a child or have that condition, the dummy variable, versus if you don't have it. So in this case, we're about 7.5 times more likely to purchase a new vehicle if we have a child versus if we don't have a child. Any questions? So that's our second step. Our second step is interpretation and statistical significance. We found each of these variables was statistically significant, and now at this point, we've been able to interpret all three of these. We feel pretty good about this. So we found each of them has some effect. Well, some of it, like income, seems like it's very small. You have to remember, income we're talking about for every additional $1,000, so eventually it could add up. Where oldest vehicle, you know, we're talking probably your oldest vehicle is not going to go much above 10 or 11 or 12. Income can keep on going up. And then child, well, it seems like a large effect. Again, yeah, it's just one little thing that we're looking at. And it's one thing that we think really would affect your odds. Questions? Our third step I'm going to call goodness of fit measures. And we're going to do a few different things here. So, we want to do a few different things in the goodness of fit measures. So, the first thing that we can look at for goodness of fit is sort of four, I'm going to give 4 titles, but they're really looking at the same thing. One is called sensitivity. Specificity. False positives. And false negatives. So we can look at these 4 items. Sensitivity, specificity, false positives, and false negatives. Now, we're going to be able to get all of this information in this case from SPSS and from our output here. Okay. Now, what sensitivity is Sensitivity is that you correctly predict that you purchase a new car. Sensitivity is that you correctly predict the yes behavior in this case. So whatever you've labeled yes is your dependent variable. So whatever is the yes, so in this case purchasing a new vehicle, the question is, does a person smoke? The question is, does the state vote for Barack Obama? Whatever the case may be, whatever you've specified as one is sensitivity. So correctly predicting, in this case, whatever that one answer is, or in this case, that you purchase a new vehicle. Now, where are we going to get that information from? Is we're going to get from the classification table. So in this case, what the classification table is going to tell us, in this case, is that we correctly predicted 71 of the people who purchased a new car. So what we did is, in this case, we predicted here, actually, let's see, that's 97. We predicted that 97 people would purchase a new car. And in 71 of those cases, we correctly predicted that they actually did buy a new car. Okay? So in this case, we predicted that they would buy a new car, and it turns out that they actually did. Okay? So that's what's going on in the classification chart. What we have here is we have 359 cases where we predicted they would not purchase a new car, and they did not purchase a new car. Okay. That's what this number is. 26 is the number of people who we said we think they're going to purchase a new vehicle, but they didn't. We have 44 cases where we said they're not going to purchase a new car, but in reality they did. And then finally we have 71 cases where we predicted they would purchase a new car, and we correctly predicted that they would purchase a new car. Okay. So we predicted it, and they actually did purchase a new car. Is everyone okay about what is in this table so far? All you have to do is follow the 2x2 here. Not purchasing a new car, predicting that you did purchase a new car. Here, the 0 means that you didn't actually purchase a new car, and 1 means that you did purchase the new car. So in this case, sensitivity is that you correctly predicted that you would purchase a new car. So in this case, sensitivity is So sensitivity is the number that correctly predicted a new car and actually did purchase a new car. Okay. So in this case, we have 71 cases where we correctly predicted that you would purchase a new car. Okay. So we're looking at all those people that purchased a new, or that we predicted would purchase a new car, and that we correctly predicted. And there are 71 cases like that. Now, the number of times we predicted that you would purchase a new car,